Hi guys, sorry I can't be at school today, but I'm making this recording to teach you about valence electrons. How exciting! Before we begin, let's review the model of the atom. As you guys know, an atom has a nucleus, which contains protons and neutrons, and the nucleus is surrounded by electrons and empty space. You guys already know that electrons are located in a cloud around the nucleus. But, like Bohr said, electrons exist in different energy levels within that cloud. So in this cloud, you can see two energy levels. There's one close to the nucleus with 2 electrons, and there's one far away from the nucleus with 5 electrons in this case. So these are the electrons that are involved in chemical bonding. Now I'm going to introduce some new information to you. Feel free to pause, rewind, or watch this video again if you want to hear the information again. Today I'm introducing to you the term valence electrons. These are very, very special electrons. They are electrons that live in the outer energy level of an atom. Here you can see boron has a total of 5 electrons, but only 3 valence electrons because there are 3 electrons in the outer energy level. How cool is that? Here you can see silicon has 14 electrons total, but only 4 valence electrons because there are 4 electrons in the outside energy level. Finally, you can see antimony, which has a whopping 51 electrons, but only 5 valence electrons because only 5 electrons in the outer energy level. The periodic table can help you figure out how many valence electrons different elements have. On my periodic table, I wrote 1VE above this group to show that this group has 1 valence electron. I recommend you pause your video now, take out your periodic table, and label your periodic table like I've labeled it. 1 valence electron in group 1, 2 valence electrons in group 2. We're going to skip this big section here for now. 3 valence electrons in group 13, 4 valence electrons in group 14, 5 valence electrons in group 15, 6 valence electrons in group 16, and you guessed it, 7 valence electrons in group 17. Here I have written that there are 8 valence electrons in group 18. And that is true for all the elements in group 18 except helium. Helium only has 2 electrons total, and both of them are in the outer energy level. So helium actually only has 2 valence electrons, whereas the rest of the noble gases have 8 valence electrons. Valence electrons are in the outer energy level. So I need to tell you a little bit about energy levels, which can also be called energy shells. First of all, electrons fill these shells from the inside out. So the first shell that electrons will fill are energy level 1. And energy level 1 can hold up to 2 electrons. So if an element has more than 2 electrons, like most elements do, then you would have to go on to energy level 2, which can hold 8 electrons. But if an element has more than 10 total electrons, then you have to go to energy level 3, which can hold another 8 electrons. We are only going to be looking at energy levels 1, 2, and 3 in middle school. In high school, you'll learn about all the other energy levels, so you have something to look forward to in high school. So let's take a break and let's try to figure out what element we're looking at here. This is showing the valence electrons for an element on the periodic table. I can see that in the first shell there are 2 electrons. In the second shell there are 6 electrons, which means this element has 6 valence electrons and a total of 8 electrons. Take a minute to look at your periodic table to see if you can figure out what element this is. Have you found an element on your periodic table that has 8 total electrons and 6 valence electrons? If you said oxygen, then you're correct. Now, I need to talk to you a little bit about why valence electrons are important to elements. And on my slide I say, what makes an element happy? And you're probably thinking, Miss Slabosky, elements don't have feelings. They don't have brains to have feelings. Well, you're right, but I sometimes like to use this emotion to describe elements that are stable, inert, and non-reactive. So elements that do not like to react with other elements are happy by themselves, and I call them happy. What you need to know is that when an element has a full outer shell of electrons, that element is happy or stable and non-reactive. So let's talk a little bit more about that. Here you can see 3 elements: sodium, chlorine, and argon. Sodium has a total of 11 electrons and 1 valence electron. Is sodium happy? No, because it only has 1 electron in its outer shell, and that outer shell could fit 8 electrons. Chlorine has a total of 17 electrons and 7 valence electrons in its outer shell. Is chlorine happy? No, because chlorine wishes it had 8 electrons in its outer shell. Now, let's look at argon. Argon has a total of 18 electrons. That's 8 valence electrons. Is argon happy? You bet. Sodium is very reactive because it wishes it could lose its valence electron so that this shell, the second energy level, would be full. Chlorine is sad because it wishes it could gain 1 electron so its energy level 3 would be full. Argon is a winner. Argon is happy because its outer shell, energy level 3, is full with 8 electrons. That's why sodium and chlorine are both very, very reactive elements. And argon is a very non-reactive element. It's a noble gas. Remember, nobility makes you think of royalty, makes you think of kings and queens who don't like to interact with anyone else. That's argon. I hope you have a better understanding of what a valence electron is after listening to this video. You could also refer to your homework in your book about valence electrons. But now I want you to try to fill in your chart of valence electrons that the substitute teacher gave you. Good luck. See you tomorrow.